welcome you to another episode where we shall be looking at the mathematics paper 2 for grade 9. Okay. So this paper has usually around about 5 topics. Okay. So we have the first question, which is the multiple choice. Okay. Now, question number 1. They're telling us that we have 4 options and then we must choose the correct one. They are asking us for the statement that is true about the figure. Okay. So they're telling us, did they tell us if these lines are parallel? Okay, let's assume these lines are parallel. What will be happening? Is A1 gonna be the same as B1? That is true. These are corresponding angles because of parallel. That is perfect. A1 the same as B3? Yes. A1 is gonna be the same as B3. Exterior angles, no. The reason is wrong. A1 is the same as A3. Vertically opposite angles. That is correct. Is A1 plus A2 equal to 180? Co-interior angles. A1 and A2 are not co-interior. So this is wrong. Now my problem is we have 2 angles that are the same. Which statement is true about the figure? True A1 and B1. Those are corresponding angles. Statement is correct. Then A1 and A3, they are vertically opposite. So whichever option between A and C. Okay. A or C, one of the two. Then complete if a triangle is equilateral. Okay. Now we know that an equilateral triangle, all the sides are equal, and then all the angles are going to be 60. Okay. They want us to get the size of C1, which is the exterior. Remember, exterior must be the sum of these 2 interiors. So 60 and 60 should give us a 120. So C is the correct option. Then a quadrilateral is quad. Quad means 4. Lateral sides. So 4 sides. So a 4-sided polygon, which is C. Then 1.4, which of the following is true about the diagonals of a kite? So one thing we know is that these diagonals, they meet at 90 degrees. Okay. Diagonals are equal? Wrong. Diagonals bisect each other? No, it's only one that is bisected for a kite. So this is out. The longer diagonal bisects the shorter diagonal at 90. There's a lot of truth there. The shorter diagonal bisects the longer diagonal at 90. I mean, if this is our kite, then we have something like that. We're saying this is our diagonal. So to bisect is basically to divide into 2 equal parts. Okay. So there's no way that we can say that this is equal to that. No. But we can simply say this and that can be equal. So the longer diagonal bisects the shorter diagonal. Option C is the best option there. Then 1.5. Which of the following is not a property of congruence? Now remember, congruency is when shapes are identical in sides and in angles. So side, angle, side, angle, side, angle, and angle. Which of the following is not a property? So let's eliminate. So remember we said for congruency as well as similarity, the angles have to be the same. Okay. Angle, side, this is a property. Side, angle, side, that is also a property. Then side, that's a property. So I'm going to take out the not to be a property since it applies to both. Okay. Then the reflection of this in the y-axis. Now, when you're reflecting in the y-axis, the sign on the x must change. If it was negative, becomes positive. If it was positive, becomes negative. The sign of the y coordinate. Is it y coordinate or x coordinate? It's the x coordinate because you're moving here, you're coming this side. So if originally it was a 4, 2, our final answer has to be negative 4 and a 2, which is option A. So the sign of the x coordinate must always change. Then this rule, x minus 3y plus 1, means that the point xy is being translated 3 units to the right and 1 unit down. No. No. So x minus 3, you're translating it downwards. And then, okay, so horizontally, we're using 3. Vertically, we're using 1. So which means with a y, it's going to move 1 unit upwards. Let's start by looking at that. So 1 unit up, there we go. Then this is 1 unit to the right, 1 unit to the left, no, 1 unit down. So I think this is the best option. 3 units to the left, since we are subtracting a 3, and then 1 unit up. So option D. So minus in the horizontal, it's to the left. The minus in the vertical, it's down. And the opposite is true. The sketch below, the circle has a radius of 4 centimeters. What is the area of the shaded? So we've seen that half of the circle is shaded. So we know that area of a circle is given as pi radius squared. So pi, the radius is 4. Then this is going to be 16 pi centimeters squared. But since our half is shaded, we're going to divide this by 2. So that our answer becomes 8 pi. Option B will be the best. 1.9. The volume of a cube whose height is 4. We know that a cube has all the sides being equal. 4, 4, 4, 4. And we know that volume will be the area of the base multiplied by the height. Or with a cube, just get the length to the exponent of 3, which is 4 cubed, which gives me 64 centimeters cubed. So option B will still be the best. Then 1.10, the surface area of the square prism. So with the square prism, we know that one face is going to be L squared. But since we have 6 faces, we just multiply this by 6. That will give us the total surface area. So it's going to be 6 times 10 squared, which is 6 times 100, which should give me 600 centimeters squared, which is option D. Then question number 2. They want me to calculate, giving reasons, the size of X, Y, and Z. So these are parallel lines, okay? First things first. If this is a 70, we know that X is also going to be a 70. So I'll say X is a 70. A reason, those are vertically opposite angles. So this is the statement, and this is the reason. Okay. Then we can see that Y is a 70 also. We can use the alternate, or we can use the corresponding. Remember, alternate is when you look at the Z. So this must be the same as that. So we can say Y is a 70. Tell us those are alternate angles because AB is parallel to CD. This part is a must, guys. You leave it out, it's as good as you not giving a reason. Okay? And then for us to get Z, we know that if this is 110, if this is a 110, even this can be a 110 because they are creating an F. So 110 and 110. So we can say those are corresponding angles. AB is parallel to CD. Alternatively, you can also use your relationship of angles on a line. But since you have a 110 and x must be equal to 180 angles on a line, then you get your 70. Or you can look at this 70 and the z must be equal to 180, and then z will be a 110. So probably it's 1 mark, 1 mark, 1 mark, 1 mark, and then you get all the 6 marks. Then 2.2. In the figure below, ABE is 65. So the whole of this angle is a 65. Okay. But DCF, this one, is a 32. Calculate the size of EBC. So EBC, they want us to get the size of this angle. Okay. What do you think? So what I'm saying is that if this is a 32, then this one is also going to be a 32. So tell us that ACB is 32 degrees because those are vertically opposite angles. Then if this is a 32, we have a Z that we are creating, or that the parallel lines are creating. Okay, this kind of Z. So, which means this angle alone is going to be a 32. Remember, they told us this entire B is a 65. So you're going to say that ABC is going to be 32 degrees. Those are alternate angles because EB is parallel to DA. Okay, so 2.2.1 is done. 2.2.2, they want the size of CAB. CAB, this angle here. So they want the angle A. So angle A, I'm going to combine it with the 65 because I know that these two will form co-interior. So A plus B must give me 180 degrees. Those are co-interior angles because EB is parallel to DA. Okay, but since our B is 65, which means my A is going to be 180 minus 65. When I punch that into my calculator, I'm getting 115 degrees. So that is 2.2.2. And then 2.2.3, calculate the size of FCA. FCA, this outside angle here. So for the outside, I can look at this 32 and this one and say that FCA plus the 32 must give me 180. Those are angles on a straight line or angles on a line. Or alternatively, what we normally say is these are adjacent supplementary angles. Okay, this is so perfect. That angles that are next to each other must add up to 180. Then FCA is going to be 180 minus 32. Okay, 180 minus 32, which is a 148 degrees. So that's how we get 2.2 done. Question number 3. Okay. Question number 3 are telling us that in this triangle ADF, FD is produced. Okay, to see AF is the same as ED. Okay. Then CD is 125. Follow the sequence of steps to calculate the size of E. Okay. Now they are telling us that D1 and D2, these two angles, they must give us 108 degrees. The reason being, these are adjacent supplementary angles. They are next to each other, so they must add up to 180. So they are angles on a straight line. Then we are seeing that D1 has to be the same as F. Okay. Remember, they told us this is equal to this. So this is an isosceles triangle. And the reason is going to be, do we need the reason? They don't want the reason. They need us to get the value. Let's get the value first. So if they're 180, let's get the, if this is 180, what is 180 minus 125? So 180 minus 125 gives us 55. So D1 will be a 55. Okay. Then they're telling us that D1 is the same as F, and then they want the reason. So this is going to be angles opposite equal sides. And then E plus F plus D1. This must give us 180 because E, F, and D1, these are angles that are inside of a triangle. Okay. So angles in a triangle must add up to 180. Then they want us to get E. So if this is a 55, this is also a 55. We need to get E. So 55 plus E should give us 180. That's going to give us, is it 110? 55 times 2 is 110. Okay. Then 180 minus 110, that is going to be a 70. So that's how we would get the 6 marks. Then 3.2 is a quadrilateral. The diagram STV is a quadrilateral with angles that are having X with them. Calculate the value of X. So if these are interior angles of a quadrilateral, they must all add up to 360 degrees. So what I'll do, I'll say 8x plus 4 plus, we have 4x plus 4 plus, this is going to be x minus 4, but then I'm adding 5x minus 4. This must give me 360 degrees. So you can say the angle sum of a quad. Okay, so let's collect the like terms. 8 plus 4 is 12, plus 1 is 13, plus 5, that's 18x. This is a 4, this is 8. You subtract 4 is a 4, subtract 4 is a 0. Then is equal to 360. I'll divide both sides by 18. This cancels that. So 360 divided by 18, I'm looking at a 20. Okay, so X is going to be 20 degrees. So this is the reason they needed. And then those are the statements. Okay, then 3.3. Telling us that NMPO is a kite with two sides being equal, and then these others also being equal. We have a diagonal MO, which bisects NOP. So the word bisecting is dividing. So if that's a 35, this must also be a 35 also. And OP, and OP, and then this NMP. So which means even this is a Y. If that's a Y, that's also a Y. Determine giving reasons the values of X and Y. Okay, so what we can see is that if this is a 35, this is 100, we can find Y. So Y plus 100 plus 35 must give us 180 if I'm focusing on triangle MOP. Okay, then Y will be 180 minus 135. 180 minus 135, which means Y becomes a 45. Okay, then if Y is a 45, this is a 35, we can find X. So X plus 45 plus 35 must give us 180 also. This is the angle sum of a triangle. Same reason can apply here. Angle sum of a triangle. So then that's going to be 180 minus 80. So X becomes 100 degrees. So opposite angles are equal, as much as this may not necessarily be equal. Alternatively, without calculation, it was meant to be known that the opposite angle or one pair of opposite sides or opposite angles are equal in a kite. Then 3.4. In the diagram below, AC is the same as AB, and then BD is the same as CD. Prove that ABD is congruent. So those three lines horizontally, they mean congruency. Okay, so for congruent, we need to look at exactly the same shape, exactly the same angles. So AD is the same as AD. So in other words, both triangles are sharing the same side, which is AD. So the reason we say or we give is that that side is common. Then AB is the same as AC, it's given. BD is the same as this is also given. Therefore, ADB is congruent to ADC. We've been looking at all the sides. So we're going to say side, side, and side. All right. So that is how we would get those 2 marks. Then in 3.5, they want us to prove that, no, they're telling us that in PQR, ST is parallel to QR. Okay. Can we prove that PST is similar? Those 3 vertical lines stand for similarity. Remember, similarity is when the shapes have the same angles and then the sides are in proportion. One is bigger, the other is smaller. So what we're going to do, what we're going to say is that we can look at the sides. Since the lines are parallel, we know that this must be the same as that because those are corresponding angles. So I'm going to say S1 is the same as Q. Those are corresponding angles because ST is parallel to QR. Okay. Then T1 is going to be the same as R. Those are still corresponding angles because ST is parallel to QR. Then we can see that both triangles, let me just highlight the 2 triangles. Okay. So PST. And then we have PQR. So both triangles are having the same angle. So tell us P is the same as P, which is common. Okay, it's a common angle. Now, for as long as you have 3 facts comparing the 2 triangles, then draw the conclusion and tell us, therefore, PST is congruent to PQR. Reason, it's going to be angle, angle, and then angle. Or we can use the symbols for the angles. So that is how you get the 4 marks. Question number 4. Consider the figure below. Consider the figure below. So this represents a transformation geometry. Okay, so what we can see is that this distance from here to the y is the same as that. That is that. So this is a mirror image. What type of transformation took place from this to that? So this is a reflection. Okay, but you need to be specific. Reflection about the y-axis or a reflection in the y-axis. Then describe this type of transformation. Remember, we saw this kind of question in the multiple choice, okay? So what we can say is that the object shifts or slides 2 units to the right. Okay, this 2 is to the right. And then 1 unit down. So the -1 is for down. The +2 is for the horizontal, the right. So plus is right, plus is up. Minus is left, minus is down. Then 4.3. The figure below shows point A in the 3rd quadrant. Okay. Give the coordinates of the image of A if it's reflected in this point. So what happens is that there are 2 ways of doing this. The x is -4 and -1. What we can do, we can start by, they want the coordinates anyway, just switch them around. which means the image is going to be -1 and -4 without even drawing. If you want to draw, count how many blocks. It's 1 block and a half, which means it's a half and 1 block. So which means our A prime is going to be there. When you read off the coordinates, it's -1 and -4. Okay, so it's either that way or you just switch the points. 4.4, consider the figure below again. They want us to give the coordinates of A, B, and C. So A is 3 and 4. Remember, X comes first and then the Y. Then B is going to be 1 and 3. And then C is 4 and 1. So those are the coordinates of A, B, and C. Then they want us to translate ABC, this shape, 5 units to the left and 3 units down. So I'm going to use the same graph to draw that. Just that let me change the color to black. Yeah, it's fine. So let me start with A. 5 units to the left, 3 down. So it's 1, 2, 3, 4, 5. And then 3 down, 1, 2, 3. So this is going to be my A prime. When I look at the B, it's going to be 1, 2, 3, 4, 5. Then 1, 2, 3. Here, that is B prime. When I look at the C, it's going to be 1, 2, 3, 4, 5. 1, 2, 3. This is my C prime. And then I'll just connect this with my ruler and get my shape. Something like that. So this is the translated kind of image. All right, so that is question number 4. Question 5, which is the measurements. They want us to calculate the area of a square having this. So we know that area of a square is given as L squared, or side times side. So that's going to be 8 times 8, which is 64 centimeters squared. Then 5.2, the perimeter of a rectangle is 46. If the length is this and the breadth is this, can we determine the value of x? So first things first, we need to know what is the formula for the perimeter of a rectangle. So it is twice length plus twice the width or the breadth, okay? Twice L plus twice B. Then do the substitution that the perimeter is a 4/6. This is twice, the length is 2x plus 5, plus twice the width, which is x plus 6. So what we need to do is open up the brackets and collect like terms. So 4/6 is going to be 4x plus 10 plus 2x plus 12. So which means I'll have my 6x plus 22 is equal to 46. I need to move the 22 that side, which will give me a 24 is equal to 6x. Divide by 6, divide by 6, which means x is going to be 4 centimeters. Now, if x is 4 centimeters, I need to find out what is my length. My length is going to be 2 times 4, okay, and then plus 5, which is going to give me a 13. Then here I'll have 4 plus 6, which gives me a 10. That helps me in calculating 5.2.2, where they want the area. So we know that area is length times the width, or length times the breadth. This is 5.2.2. Okay, so 13 times 10, which is 130 centimeters squared. Okay, so that is the area of the rectangle. Then 5.3, they want us to get the area of the circle if the circumference is 52. Okay, so circumference is 52. They want us to get the area. So we know that the formula for the circumference is given as 2 pi radius. For us to get the area, it must be pi radius squared. So the only thing that is shorting from this formula is the radius. So let's use the circumference to determine the radius and then use that radius to get our area. So that's going to be 52 is equal to 2 pi radius. Divide both sides by 2 pi, divide by 2 pi. Okay, when I punch this into the calculator, that's 52 over 2 pi, which gives me 8,28. Is it a centimeter? Yes. Then I just get this and substitute it into the formula for the area, which is pi multiplied by the radius, which is 8,28 squared. 8,28 squared. And then multiplied by the pi, which gives us 215,38 centimeters squared. So that is how that question would have been approached. Then question number 6, consider the rectangular box below. We have those measurements. Then the question wants us to get the total surface area. Now, we have 6 faces, which means we must get the area of all the faces and add them together. So when you look at the bottom, it's length times the breadth. The area of the bottom is going to be length times breadth. Okay. But this bottom part is the same as the top part. So I'll put a 2 there. Plus, when I look at this side, it's breadth times height. But this side is the same as the back side there. So times 2. Then plus, when I look at this side here, it's the length and the height. But there are also 2 of them. And then I just substitute. So this is 2. My length is 8. My breadth is 4. Plus 2. My breadth is 4. My height is 2. Plus 2. My length is 8. My height is 2. So that's going to be a 64 plus a 16 plus a 32. That's going to be 80 plus 32, which is going to be 112 meters squared. So that becomes the surface area. Okay, then 6.2. 6.2. The resort manager wants to paint the inside of a rectangular swimming pool, which is 8 meters long, 6 meters wide, and 2 meters deep. What is the total surface area of the swimming pool that must be painted? Now, if you're painting the inside, which means you're going to paint 1, 2, 3, 4, and then the bottom, which is 5. So out of the 6 faces, we're only painting 5 faces. Okay, so which means it's going to be twice length and height. Okay, this and that, that's length and height. Plus twice breadth and height for this one here. And then there's just going to be 1 length and breadth, which is the bottom. The top one won't be. So it's going to be 2 times 8 times 2 plus 2 times 6 times 2. And then plus the length is 8, the breadth is 6. Okay, multiply this. This is a 16 and a 32. That is a 24 plus a 48. Okay, that's going to be 56 plus 48, which is 104 meters squared. So this is how much he needs to paint. Then 6.2.2. If 1 bucket of paint is going to paint 26 meters squared, how many buckets of paint will be needed to paint inside of the swimming pool? Okay, so 1 bucket, these are proportions now, is 26 meters squared. How about 104 meters squared? How many buckets? So we divide these two. So 104 divided by 26. That gives us just 4 buckets. So we need 4 buckets to paint the inside of the swimming pool. Then lastly, 6.3, they're telling us that the volume of a cube is this much, and it's having a side x. Calculate the length of the side. So volume of a cube is L cubed. So 27,000 is equal to x cubed. So for us to get the value of x, you must find the cube root. Okay. So the cube root of 27,000 is going to be 13. That's what the question wanted. So guys, that is that. And then I'll stop there in that case. Okay. So this we showed it up there. So I wish you all the best.